The summer of 2026 goes down as one of the most abnormally hot ever recorded in Europe. But the data points to something more striking than the heat itself. This was, in all likelihood, the coolest summer of the coming decades. That's not an exaggeration, and it's not a slogan. It's the conclusion you reach when you look at the measurements from the ground, from the ocean, and from satellites, all pointing the same way. In this video, I'll walk through what those numbers actually show, why this heat wave happened, and why it wasn't just bad luck. First, what happened? In late June, a stable mass of hot air settled over Europe, the phenomenon meteorologists call a heat dome. The mechanism is simple. A high-pressure system acts like a lid. It traps warm air underneath, stopping it from rising and cooling. Air sinks, compresses, and warms further, so heat piles up day after day with nowhere to escape. This dome formed in mid-June, just days before the solstice, and then it stalled. For nearly 2 weeks, it barely moved, producing what researchers rate as the most severe heat wave ever recorded on the continent. The temperature records show its scale. Spain reached 45.1 degrees Celsius, its hottest June figure ever measured. Germany broke its national heat record 3 days in a row, with 252 weather stations hitting all-time highs at the same time. France had its hottest day on record. In all, national or regional records fell across about 12 countries, including the UK, Poland, Hungary, and Austria. Europe has lived through brutal summers before: 2003, 2019, 2022. Each was deadly, but 2026 broke records earlier in the season and across a wider area than any of them. And one detail matters more than any single number: the timing. All of these readings came in June, early summer, weeks before European heat normally peaks in July and August. In other words, a heat wave with the intensity of deep midsummer arrived several weeks ahead of schedule. By then, farmland across southern Europe had already dried out early, and reservoirs were running low before the summer had truly begun. But the heaviest cost of a heat wave is the one that rarely shows up on a map. In cities, the danger is worse. Concrete, asphalt, and glass absorb the sun all day and release that heat slowly through the night, so the temperature barely falls, and the body never gets the cool hours it needs to recover. By early July, the World Health Organization and national agencies had recorded more than 2,000 excess deaths across Europe, and a preliminary study, not yet peer-reviewed, put the true figure, once uncounted cases are included, closer to 20,000. Excess deaths is simply the count of how many more people died than in a normal period. It's a cold term for a human reality, and behind every point in that number is a person, most of them over 65. This is why heat is so easy to underestimate. It doesn't arrive with the drama of a storm or a flood. The damage is quiet, and it only becomes visible in the statistics weeks after the heat wave has passed. So to grasp the true scale of an event like this, the most useful place to look is from orbit. On the ground, each of us only feels the temperature where we are standing. But satellites measure the surface temperature of the entire continent, and they've done it consistently for more than 2 decades. Line that record up year by year, and a trend emerges that no single hot summer can explain away. The warm regions keep spreading, the peaks keep climbing, and the heat keeps arriving earlier. And it isn't only the land. The ocean tells the same story. This June, the Mediterranean had its warmest June ever recorded, running as much as 8 degrees above normal in waters off Greece and the Aegean. A warmer sea does more than stress marine life. It pumps extra heat and moisture into the atmosphere above it, energy that can make the next heat wave hotter and the storms that follow more violent. And the important thing about every figure so far is that it comes from an instrument. A thermometer, a buoy, a satellite sensor. It records the real state of the atmosphere and the ocean, no interpretation required. Still, a reasonable objection remains. Summers have always swung between hot and cool, so what makes this one different from natural variation? This is the exact question a scientific group called World Weather Attribution was built to answer. Their method is to run the same event through two climates, today's and a simulated one without human emissions, and measure how the odds change. For this heat wave, their answer was blunt. A night as hot as the ones Europe just lived through was, in the early 2000s, about 100 times less likely than it is today. Something that used to be rare has become almost ordinary in the span of 20 years. The careful way to say it is this: climate change didn't create this heat wave on its own. Weather always keeps a random element. What it does is shift the entire distribution of temperatures upward, so extremes that were once at the far edge now sit much closer to the middle. There's also a wildcard building in the Pacific. El Niño, the warm phase of a natural ocean cycle, is strengthening, and models project it will peak in the autumn of 2026, pushing the global average temperature higher still on top of the long-term rise. Which brings us back to where we began. 2026 was, in all likelihood, the coolest summer of the coming decades, not as a prophecy, but as the simple result of extending a trend line that observations have traced for 20 years. And yet that line is not fixed. Where it goes next depends on emissions in the years ahead, and those depend on real choices about how we generate power, how we build and cool our cities, and how fast we move. Cut emissions, and the line bends down. Keep rising, and it climbs. The satellites will keep recording, quietly, year after year. The open question is whether, 1 or 2 decades from now, that record shows the warming pressing on or finally beginning to level off. Because the path of future temperatures is still a variable, not a constant, the next decade is still ours to shape. This is the first video on this channel. The goal is simple: to read the climate through observed data, especially from satellites, clearly and without exaggeration. If that's the kind of thing you want more of, subscribe, and I'll see you in the next one.